Okay, everybody, so we're going to move on here to graphing exponential functions. And as you see here on our first slide, we have 4 steps that we're going to use in order to do so. Okay, first step is going to be to find, if I can get my pen to work here, find our Y-intercept. Okay, and we always find a Y-intercept by setting the x equal to 0. So if I do set the x equal to 0, I get y equals 2 to the 0 power. Anything to the 0 power is equal to 1. Okay, this is a 0 here. Okay, so if my x is, actually I'm going to put it down here, 0, my y is equal to 1. Okay, the second step I'm going to do is I'm going to go ahead, I'm going to use my calculator to find the table. Okay, so I'm going to go ahead, I'm going to grab my graphing calculator. You should see it pop up here on the screen, and I'm going to put in y equals 2 to the x power. So in case you're not sure, grab your graphing calculator, you hit your y equals button in the upper left hand corner. I already have something in there, I'm going to clear that out. And my y equals in this case is 2 to the x power. So I'm going to do 2. And in order to raise to a power, I'm going to hit my caret sign, which is that one right below the clear button. And then my x, remember, is the button right below mode. It is not the multiplication button. So right there, that shows 2 to the x power. I'm going to go ahead and I'm going to look at my table. So second graph, and here's my table. So I have a whole bunch of values here that I can put into my table. But since I already know that I'm using my y-intercept at 0, 1, I probably want to pick the points that are around that. So I'm going to, for my table, I'm going to use -2 and 0.25, -1 and 0.5, and then I'm going to use 1, 2, and 2, 4. Okay? So I'm going to jump back to my slide here. So from my table and my calculator, I found that I can use the 0.1, 2, the 0.24, and then going the other way, the -1, and I think that was, let me jump back over here and double check, 0.5, and when I plugged in -2, I got 0.25. Okay, so my third step here is going to be to graph the points. So let's go ahead and let's graph those. Alright, 0, 1, I'll do that one in red just so we can keep in mind that that was our y-intercept, 0, 1. Then I have the points 1, 2, 2, 4. I have the point -1.5, so that's about a half, or maybe that was a little low. And then -2 and 0.25, that's even further down. Okay? Alright, now let me go back to my table real quick, and I want you to notice something as I continue to move up here. What you're going to notice is that if you look at that y value, that y value gets really, really small. And remember, once you start seeing scientific notation, that's just showing that it's getting really, really small. Okay? But that number never goes into the negatives. That number is just getting really, really, really close to 0. Alright? So for that reason, what I have is a horizontal asymptote at 0. Right here I have a horizontal asymptote that I'm never going to touch. So not only am I going to graph the points here, I'm also going to graph my horizontal asymptote. And then my last step here is just to connect my points. and it looks something like this. Make sure you put your arrows at the end, and always remember that we don't cross over these horizontal asymptotes. Okay, now quickly, let's talk about domain, range, x-intercepts, y-intercepts, horizontal asymptote. Okay, we've already found that our horizontal asymptote is at y equals 0. We don't cross over 0. We already found our y-intercept to be 0, 1. Or we could also call that, I mean, if you don't want to write it as an ordered pair, you could just write it as y equals 1. Okay, because I'm going up 1 on the y-axis. My x-intercept, now, x-intercept is always in our table wherever the y value is equal to 0. So I'm going to scroll up here, see if I ever get to a 0. Well, we already kind of looked at that. We never got to 0. We approached 0, but we never got to it. So for that reason, I do not have an x-intercept. I'm never going to cross over the x-axis. Okay, let's talk about domain and range. Domain, remember, domain is our left and right. Okay, domain are our x values. And in this case, we go all the way down to negative infinity with this graph. We go all the way up to positive infinity with this graph. So our domain goes from negative infinity up to positive infinity. Our range, on the other hand, our ranges are up and down. Those are our y values. And we do not go all the way down to negative infinity here because we hit our asymptote at the x-axis. Okay? So our range actually goes from 0 up to infinity because we do go up as far as we can go, but we do not go all the way down. We get stuck when we try to cross 0. Okay, next example. Now we have y equals 2 to the x minus 1. So I'm going to grab my calculator. It's very similar to what I already have in. 2 to the x, but instead of just x, I'm going to do x minus 1. Okay? Now for those of you that are using a TI-83, you're going to have to put x minus 1 in parentheses, okay, to make sure that your calculator knows that all that x minus 1 is all up there in the exponent. So if I look at this table, okay, I want to make a point to see that, okay, my y-intercept in this case is now 0.5. Okay, so I'm going to go ahead and I'm going to plot these points. I have 0 and 0.5. I have negative 1, 0.25. Those are getting even smaller, so I'm not even going to go that direction. 1, 1, 2, 2, 3, 4. So 1, 1, 2, 2, 3, 4. And I'll even go one step further, and I have 4, 8. So this thing looks like this. Once again, though, you'll notice that this never crosses the axis, so we have another horizontal asymptote at 0. So, a little different, but a lot the same. Our horizontal asymptote is at 0. Our y-intercept, instead of being where it was, is now at 0 and 0.5. Our x-intercept, once again, there's none because of our asymptote. Our domain, once again, goes from negative infinity up to positive infinity because we do go left and right every value. We go way down here, we go way up here. The range, once again, is from 0 up to infinity. Now, those are not always going to be the case as far as the range goes, because there's a chance that this whole graph could be shifted down, shifted over. These graphs can be shifted and they will be shifted. And that's what this last slide talks about. So to wrap up this discussion, we can kind of look at this as like our parent graph here. Okay? And then we just did this one where, okay, what happened? Well, this point right here, the point 0, 1, ended up moving over when we did the second one. Well, how did it move? Well, it moved because of, let me grab a little highlighter here. It moved because of this. Okay, well, what happens if we have that, but it's a +1, and then we also have a -2 outside of that? Well, if you kind of look at these graphs, what's happening is, in this graph, the whole thing shifted. If you look at the point in question, which is our, this is the point we really want to pay attention to, is that point right there. Okay, in this example, all that point did was move to the right 1 unit. When you get down to this example, the third example, that point went down 2 and to the left 1. So this comes back to that same discussion we had earlier. All of these different things mean something. This A here, the number in front, well, what's that going to do? That's going to stretch your Y. That stretches it up and down, left and right. Okay, and that's kind of the case over here with this one. Notice that it's a little bit taller, a little bit, it's stretched a little bit higher. What does, let me undo that. Undo. Okay, go back to my pointer. The other thing you're going to see is this number up here in front of the x. Well, we haven't seen one of those yet. What that does is it stretches the x value. It's going to make it like wider. Okay, we won't see that very often. Most importantly is this number that's after the x, just like the x minus 1 down in the bottom example, or the x plus 1. That shifts it left and right. So you'll notice in the second example, the one down at the bottom left, that thing got shifted to the right 1 unit because of the -1. In the bottom right example, that thing got shifted to the left 1 because of the +1. So that's that idea of it's kind of the opposite of whatever's attached to the x. And then the last thing is what's on the outside. That shifts it up and down. So the -2 in the bottom right hand corner, the -2 shifted it down 2. Okay? Now, for the sake of what you're going to do in class, you're going to be asked to graph these. And in order to graph these, you need to be able to grab your graphing calculator, plot them, find domain, find range, x, y-intercept, and go from there. Okay?